In this example, we're going to work out the population variance and standard deviation for a grouped frequency distribution. We need to look at what each part of the formula means. Mu, we should know, is the mean. The mean is given by the sum of all of the data divided by the number of pieces of data that we have. Mu squared, remember, means the square of the mean. So we're going to need to calculate the mean and then square it. Sigma f means add the frequencies. If we add the frequencies, we find the number of pieces of data. And the sigma fx squared means the sum of the square of each piece of data. If we want to work out the number of pieces of data, we need to sum the frequency column. If we add up the frequency column, we know we have 50 pieces of data. This column will be called F in terms of the formula. We have a grouped frequency distribution. So we know we have 14 pieces of data between 5 and 10. We don't know what they are, so we assume they're all at the midpoint. 14 pieces at the midpoint of this interval. We call this column X, and the midpoint of 5 to 10 is 7.5. For 10 to 15 it's 12.5, 15 to 20 17.5, 20 to 25 22.5, for 25 to 30 it's 27.5, and finally 32.5 for the interval 30 to 35. In calculating the mean, we already have the number of pieces of data. What we now need is the sum of the data. We have 14 pieces of data that we're assuming are equal to 7.5. To calculate the sum of these, we can do 14 times 7.5. So we create an fx column, f times x, and work out the values. 16 times 12.5 will be 200. 8 times 17.5 next is 140. 6 times 22.5, 135. 4 times 27.5, and finally 2 times 32.5. We need the total for this column, and if we add this column up, we get 755. Finally, we need the sum of squared data, sigma fx squared in the formula. So we need a column which says fx squared. The easiest way to calculate this is to do x times fx. 7.5 times 105, 12.5 times 200, 17.5 times 140, 22.5 times 135, 27.5 times 110, and 32.5 times 65. We need to total this column to give us the sum of the fx squareds, and we get 13912.5. We can now substitute all of this into the formula. Sigma squared is going to be the sum of fx squared, 13912.5, divided by the number of pieces of data, which is 50, take away the mean, 755, divided by 50, all squared. This gives us 50.24. For the standard deviation, we need to take the square root, and that gives us 7.09, correct to 3 significant figures.